All right, let's go over what you should have for A through D. Make sure this is in record mode. Okay. For A, it says write a recursive rule for the nth term of the sequence. Then you're going to find the fifth term. So on C, that the common difference between these is 1.5. So here D is 1.5. And for the recursive rule, it's just a sub n equals to a sub n minus 1 plus 1.5. That's going to be your rule. And then as far as the fifth term, n is equal to 5. So you're going to end with a sub 5 equals to a sub 5 minus 1. Some of you may just want to put a sub 4. The fourth term plus 1.5. 1, 2, 3. The fourth term will be 7.7. So you have 7 and 7/10 plus 1 and 5/10. So the fifth term would just be 9 and 2/10. 7.7 plus 1.5. So here's your rule. Here's your fifth term. And of course, if you added 1.5 to that, you could see it's just 9 and 2/10. All right, B says write an explicit rule for the nth term of the sequence. So I can see that here the common difference is -8. You're subtracting 8. It says find the 42nd term. I'm going to go back to some, guys. Forget B right now. Go back to A. If you can just write the rule for me and find the fifth term by adding 1.5 and 1.5, you don't have to do this. This part, you don't have to do. Just be able to write the rule for me, because I consider this part a waste of time when you can just take 6.2, add 1.5, and then take 7.7 and add 1.5 that way. This to me down here, like I said, this is a waste of time. Just be able to write that rule for me, okay? All right. So go back to B. I'm going to use the rule, the explicit formula, a sub n equals to a sub 1 plus n minus 1 times d. So I have a sub n equals to the first term, which is -9, and n minus 1 times the common difference of -8. So a sub n equals to -9 plus -8n plus 8. Come here. Good morning. So a sub n equals to -8n minus 1. Hold on, guys. I'll be right back.
That's your pencil. All busted up in there. And he said, there were pencils all over my truck. I picked up as many of them as I could. So I'm just glad to see them. So,
Why so long?
I don't know. Like I said, the package had to leave Friday. I said, you must have got those out of the ditch.
I think so.
And he said, no ma'am, no ma'am, no ma'am. And I said, I believe you did.
I think these were in a ditch too.
I really do.
Yeah, I do. I think they were in a ditch.
So,
And
then there's a pencil sticking through this.
Look at this.
Yeah.
This is ditch material.
Uh-huh.
Yeah. And they found a second dump site.
Yeah.
Somebody didn't want to work. Thank you.
Have a good day.
Thank you. All right, guys, so that's the rule. And then the 42nd term, now n is going to be 42. So you're going to end up with a sub 42 equals to negative 8 times 42 minus 1. Excuse me. It's 8 times 42. Negative 8 times 42 is negative 336 minus 1. So the 42nd term is negative 337. So here's the rule, and here's the 42nd term. C says write an explicit rule for this. I see that the common difference is 2. Then you're going to find the 81st term. So the rule is a sub n equals to a sub 1 plus n minus 1 times d. So we end up with a sub 1 being replaced with 1 plus n minus 1, and the common difference is 2. So the rule is a sub n equals to 1 plus 2n minus 2. So you end up with 2n minus 1 for your rule. And then, of course, you want to look for the 81st term. So a sub 81 equals to 2 times 81 minus 2. So that's 162 minus 1. I think I said minus 2 earlier. 162 minus 1. So the 81st term is 161. And here's the rule. D says write a recursive formula to find the 6th term. And I can see that these are going up by 6. So I know D is equal to 6. So we end up with a sub n equals to a sub n minus 1 plus d. So that's a sub n equals to a sub n minus 1 plus 6. That's your rule. And guys, I don't care if you do this. Add 6. That gives us 42. Add 6, and we're looking for the 6th term. 1, 2, 3, 4. Add 6, that gives us 48. That's 5. Add 6, that gives us 54. That's the 6th term. So I'm going to put a sub 6 equals to 54. I don't care if you do that. To me, it's dumb to do the other one. When I say the other one, I mean it's dumb to do all of this when I can just add the common difference on the recursive formula. So a sub 6 equals to 54. Now let's take a look at E. E says use the sequence to complete the table, then graph it on the coordinate plane to the right. So we're going to talk about what this looks like.
Miss Pryor to the office. Miss Pryor to the office.
I'm so sorry, guys. I meant to make this video last night. I forgot. All right, so the first term, that's where the N stands for the term. And a sub n is your actual number, okay? Like this first term, I got negative 8. The second term is negative 5. The third term is negative 2. The fourth term is 1. The fifth term, this is the fifth one, is 4. So let's see what the sixth term would equal since we understand the chart. So the sixth term, let's find the common difference is adding 3. So the sixth term will have to be 7. And the seventh term, if I add 3 here, would be 10. And the eighth term, if I add 3, would be 13. All right, it says graph it. After we finish it, graph it. So for 1, think of this as a coordinate plane, as a order pair. 1, negative 8, 2, negative 5. The first term was negative 8. 1, 2, 3, 4, 5, 6, 7, 8. The second term was negative 5. The third term was negative 2. The fourth term was 1. The fifth term was 4. These little things are small, so hold on. 1, 2, 3, 4. The sixth term was 7. The seventh term was 8. The seventh term was 10. 1, 2, 3, 4, 5, 6, 7, 8, 10. Okay, and I can't get the 8th term on there, so it's fine. All right, so it says, is this a function? Well, just looking at it, these will be considered as my x's and these will be considered as my y's. In other words, input and output, or domain and range. But look at your x's, none of them repeat. None of your x's repeat, so it will be considered as a function. Or you could just look over here at the graph and see that everything passes the vertical line test. If I draw a vertical line, there's only one point in that line. Only one point in that line, only one point in that line. So I see that these arithmetic sequences are also functions. It is a function. How do you know? It passes the vertical line test. I should say the graph passes the vertical line test. Or I could say none of the, instead of x values, n values repeat. It's actually n. Look over here. It says, what else do you know about the points on the graph? Well, these points also are in a straight line. So if they're in a straight line, so an arithmetic function is not only a function, it is what we call, excuse me, take that out. It's what we call a linear function. Linear meaning line. It's a function, but it's a specific kind. It's called a linear function because if I graph these things, they form a straight line, guys. All right, I'm going to make the video for the real life application problems during my planning period, which is at 1 o'clock. So I won't post this video for F and G until, I don't know, maybe about 1:30. And then you will have to finish your homework tonight. Your homework has maybe 1 or 2 application problems in it, but you can start on your homework now, except the application part. All right, thanks, guys.